Good morning, students. Can I see the screen? Can you hear me?
Yes, sir. Yes, sir.
All right. Sorry for the late start. Sorry for the late start. All right. So we're gonna practice some of the statistics questions. Because remember we missed last week, so it kind of a little bit back, but we will catch up. So my plan originally was to do the statistics and the plane geometry today, but I feel like this topic is so important. It's better to just focus on just clearing some of these statistics questions from the past papers for practice today. I think I'd sent you about 4 or 5 questions in the group for persons to do. 1, 2, 3, 4, 5, 6, actually 7 questions. Wow. I'm going to see how many of them we can finish in this quick 2-hour session. Starting with the one on the screen, which is the January 2023 paper 2. All right, and this is number 5. Statistics on your exam paper. It's going to be number 5. All right, so let's go. All right, so this question gives us a cumulative frequency curve. That's what it gives us, a cumulative frequency curve. And it shows information about the time taken by 200 students to solve a math Olympiad problem. All right, so remember now that the students are up here, the 200 students, and they are arranged from the one who took the shortest time down here, just to appreciate the graph, to the ones who took the longest time up here. So the shortest time students are at the bottom, the longest time students are at the top. And you could say, okay, the students down here took these short times down here. And the students at the top put the long time out here. Now, also remember that the graph is actually not showing the exact time that they took, because we don't have that information, because generally speaking, a cumulative frequency graph is drawn when the data is grouped and you don't know exactly the time taken by the students. So a graph like this will be drawn from group data. And so it is either a less than time graph or a less than or equal to graph. No, they did not put any dots, any points on the graph for me to know exactly. But sometimes as you read, you will know. All right? So what I'm going to assume is that it is a less than for now. Assume that it's showing how many students took less than any given time. So for example, if you want to know how many students took less than 30 minutes, right, then you could come to 30 minutes here, come up on a graph, and then read that number of students across here. Now, one important thing we should have done before we started was to figure out the scale of the graph. All right? Figure out the scale of the graph. All right, let me leave that so we can know exactly what measurement that is, or what number of students that is. So let's zoom in on it. So if you notice, there are 5 intervals between 0 and 20. We're trying to figure out what each of these the squares mean. All right, or those like dimensions. So there are 5 of these. 1, 2, 3, 4, 5. 5 of those small intervals between 0 and 20. So it means that each one of these, from here to here, for example, is 20 divided by 5. Because total number of students is 20 and there are 5 intervals. So each interval is 20 divided by 5, which is 4. So it means then that we're going up by 4. So this is 4 students, 8 students, 8, 12 students, 16, and then 20. All right, as you can see. So that's one of the first things you want to do, figure out the scale of the graph. So each of these intervals represent 4 students. All right. Then on the horizontal axis, we're talking about the time, less than time in minutes. And this one kind of easy because there are 10 intervals, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 intervals between 0 and 10. So 10 divided by 10 is equal to 1. So each interval is 1 minute. So that one is clear on the horizontal axis. You always want to analyze the scale before you start answering questions. Don't assume. All right. So on here, each interval is 4 students. Down here, each interval is 1 minute. All right. So establish that. All right. So back to the graph. So this therefore, right here, therefore, will be 4 below 80, which means 76. All right, will be 76 students. So that would basically mean that 76 students took less than 30 minutes to finish the test or finish the question. That's what this would mean. 76 students took less than 30 minutes. You can see it now. All the time down here is less than 30 minutes taken by all the students down here on this part of the graph down here. All right, so 76 students took less than 30 minutes. And that's what you read a cumulative frequency graph, basically. All right, that's very important. That's what you read a cumulative frequency graph. If you want to know the time, for example, that say 100 of the students took less than, so you want to know the time that 100 students took less than, then at 100, you come across on the graph, able to hear and you read that time down here. What would that be? That would be 30, 31, 32, 33, so 33.5 minutes. So 100 students took less than 33.5 minutes to complete the task. That is how you read a cumulative frequency graph. So we need to establish that. Right? You have to know how you read the graph. Well, let's answer the questions now. It says, using the cumulative frequency curve shown above, find an estimate. And you see, everything that we do when the group data is grouped is estimate. So that's how you know the data is grouped as well. You have to estimate everything you do when the data is grouped. Because as I said, you don't know the actual measurement of the scores. All you know is how many scores scored less than, how many students got less than a certain time. So we're trying to estimate now the number of students who took more than 50 minutes. Remember, the graph is going to show you how many took less than them. So the rest of them would have taken more. All right. So let's see how many took more. So by them saying more here, I'm therefore going to change this to say the graph show me how many took less than or equal to a certain minutes. It looks like the less than or equal to graph based on this graph because it is known, right, that when we go to 50 here, it's going to tell us how many students took less than or equal to the 50 minutes. And therefore, the rest of them would have taken more than the 50 minutes. All right. So what you want to do? You want to come out to 50 here and read that 50 up on the graph, up to here. Read it up on the graph to here. That's a 50 line. And 50 takes you right up to here, and then you come across and read it on here. So this is the number of students who took less than 50 minutes. Remember now, this interval is 4. So if right here says 200, then here is 4 less than 200, which is 96. So 96 students took less than 50 minutes. And so the rest of them at the top took more than 50 minutes. You can say it like that. Or 96 took less than or equal to 50 minutes. So the rest of them took more. So let's write it like this. 96 took less than or equal to 50 minutes. Therefore, the rest of them is 200 total. 4 students. Took more than 50 minutes. I could put greater than 50 minutes. Let's put greater than 50 students took greater than 50 minutes. Let me change this word to 96 took. 96 took less than or equal to 50 minutes. So the rest of them, 4 of them, not 96, no, 196. My mistake, it's actually 196. 196. But understand that?
Yes, sir. Yes.
All right. Then it want the median time taken. So the median time is the time taken by less than, or the time taken by approximately the 100 students. Since there are 200 students in the survey, the median time is time taken inside here by the 100 students, half the number of students. So this would be the position of the median right here. 100 students is the position of the median mark. Right? That's the position of Q2, the 100 student. So you want to know the time that this time that was taken by less than or equal to 100 students, approximately. So you come across on the graph to here, come across on the graph until you reach the graph here, and you read that time down. Look like right in between these two marks. That is the median time right there. Remember the scale, that's 30, 31, 32, 33, 33 and a half. Like we did that earlier. That's 33 and a half. So this is Q2, which is 33.5 minutes. So that is approximately the median time. And by putting these marks on the diagram, I'm showing how I got my answer. So I'm leaving these marks, these lines that I drew on the diagram. And so I can just write the answer right here because I have it here. So the median time Q2 is 33.5 minutes. I'm going to put MIN on this, minutes. So far, so good? But okay?
Yes, sir.
All right. Next question says, the probability that a student chosen at random took at most, no, at most really means less than or equal to, means 28 minutes is the most. It means less than or equal to 28 minutes. So you see, I concluded that that's the type of graph that I have based on these questions. That's what I expressed to you in class, that your graph is either showing less than or it's showing less than or equal to. Based on this question, it means that this graph is showing less than or equal to. But first it asks me how many took more than 50. And now it's asking me how many took at most 28. At most 28 means all I need to do is find how many students that and divide it by total number of students because I want the probability. I need to find how many students actually took less than or equal to 28 minutes and divide it by 200 students. All right, so let's see. So less than or equal to 28, less than or equal to 28 minutes. Was it done? Less than or equal to 28 minutes by how many students? Let's go on the graph, find 28 and read it up on the graph, 28. About 28 minutes, so this is 28 right here. Let me use a different color for this one. Let's use the blue. So this is 28 minutes right here, it's 28. So you come up on the graph, it's going to tell you how many students took less than that time. So you come up on the graph here, all right, until I reach about there. And then it's this point, and I'm going to read across on the graph. That is actually 64. Remember, each of these little intervals, each of those intervals is 4. So this is 64. So this corresponds to 64. Next extend it out here. This is 64. So 64 students took less than or equal to 28 minutes. So it's that 64 students out of the 200. So let's write it down here. So see it here. Less than 28 minutes was taken by 64 students. Therefore, the probability of taking less than or equal to 28 minutes is equal to 64 divided by 200, which is 32 divided by 100, which is, you can leave it as a fraction, or you can write it as a decimal, 0.32 is the probability. Or I can leave it as a fraction. So people even express probability as a percentage. It doesn't really matter. But I got at that?
Yes, sir.
All right, then it says now, using the graph, using the curve, we have to complete the table. All right, so using the graph, using the cumulative frequency graph, we have to complete the table below. All right, let's see what we have from the graph. So we have these midpoint values. We have these frequencies. And we have these, we're trying to complete this, which is the sum column. So this is a sum column. All right. So what it is, these are the midpoint values. But remember, the cumulative frequency graph is showing you how many students got less than or equal to these marks. All right. So if you try less than or equal to 10, you're gonna see that that is 12. All right. So what you can do to get the actual frequency, what you can do to get the actual frequency, you can see how many students are in between 11 and 20, or preferably in between 10 and 20 to go inside here. And then how many students are in between 40 and 50 to go inside here. And then you see that number of students between 50 and 60 is inside here. What you can also do is put in cumulative frequency column instead and read those values directly from the graph. So I'm going to do it for you now, but they don't absolutely have to do it. I'm going to put in a cumulative frequency over here, column, just to add, just to show you how you could do it from the graph. Cumulative frequency that you can read directly from the graph. And then from a cumulative frequency column, you can then find the frequency by subtracting. But you could also, as I said, find out how many students is in that interval on the graph to know the value for here. So let's look at it. And let's work 2 ways just to show you. All right. So let's say I got to 10, there were 12 students, right? And let's match that up on the graph. All right. So for the purpose of showing that, I'm gonna use a different color. Use a different color. So let's say I equal to 10. Let's see what 10 corresponds to. See here, you can see that 10 corresponds to 12. See here, 10 corresponds to 12. That's 12. That's why the cumulative frequency for that is 12. The cumulative frequency is 12 to start, because the frequency is 12. See, between 1 and 10 is 12 in the first interval. That's in this interval here. 12. Then now you want to know what 20 corresponds to. So if you look at 20, go up on the graph here, and it will look like right in between these 2 points. I'm going to see what this is. So this is now 20, 24, 28, 32. That's 32, you know. Let's zoom it up. This is 20. Let's go again. Let's go again just to make sure. So this is 20, right? This is 24. Each interval is 4. This is 28. And this one is 4 more makes 32. Then 4 more makes 36. So it means that this mark is 34. All right. So right here is 34. This one is 34. So in between here and here is 34 minus 12. 34 minus 12, that's 22. So I would say the second interval is 22. So the second interval is 22 right here. Second interval right here is 22, because the cumulative frequency that matches 20 is 34. That's cumulative frequency. And you can see that you have to add 22 to this to get 34. That's why this frequency is 22. All right, let's look at the next one. So the next one, so you can do it by the interval, I can do it by the values, your choice. The next one is 30. All right, 30. So you come up on the graph for 30. This is the line for 30. And so that is right on this line right here. That is 4 less than 80, which is 76. This is 76. So it means that in between here and here is that interval, 76 minus 34. That is 2, 4, that's 42. 42 in that interval, right? That interval is 42. So I'm gonna put 42 in that interval down here. Oh, they have it there already. See, they have it there already. That's because we got 76 right here. So you see the 42 is matching. The next interval is actually 84. Let's check it. And 10, therefore, must go up to what? Let's see what 10 goes up to. So you have to add 84 to this figure. Add 84 to this figure to get this one. Add 84. Well, let's see what the graph tells us, right? So the next one is at 40. Let's start equal to 40, which is this mark, 40. So go up on, I'm just showing the consistency with it. Up on this graph, all the way up here with 40, up to here. And then you come here, read it across, and it's 160 exact. This line, 160. So the next interval up here is 160 minus 76. That's the next interval. If you're filling out the interval, the frequency in the interval. So if you subtract this, you're gonna get what is this now? 5, 1, that's 4, 15 minus that is 8, 84. So the next interval is 84. So if you come up here, you see the next interval is indeed 84 because the total came up to 160. I'm telling you this column not necessarily, but I'm just showing you how you could populate a graph from the thing. And look here, this figure now is easy to find enough because you know that the total is 200. So to get the figure inside here, you could actually add up all of these and subtract from 200. But let's continue still as if we didn't know and see if the figure that we get inside here matches the 200. So the next limit value is 50. All right, that's what 50 takes us up to, so we can know what this is, the interval for that. Whatever the interval is between here and here is the figure for here. Let's see what it is. All right, so 50. Let's see what 50 takes us up to. Oh, we had it already. 50, remember, we had it from the beginning, took us up to 96. 50 took us up to 96. So you're basically looking at the interval between 96 and 60, see, between here and here. Between 96 and 196 and 160 is 36. 196 minus 160 is 36 right here. So the next interval is 36. For the next cumulative frequency is 196. All right, so it's 36. This is 36 right here. And the next cumulative frequency is 196. Then the last value is 200 right at the top. Let's say I got to 60 is 200, which matches the 4 that you'd have to add to this. So the 196 plus 4 would give you that value. So that's the table completed. And I was putting in this column for you because sometimes Christian will ask you for that. All right, so far so good, guys. Just to show you how you get the graph from the or you get the table from the graph. Something that you have to practice. Something they've been asking in CSEC in recent times. How do you get the frequencies table from the graph? All right. Remember, the frequency values are the values in the intervals. The values in the intervals. So the interval in here. First interval is 12 down here. The second interval is between 34 and 12. The next interval is between 60 and 34. 64 and 30, no, 74, sorry, 76 and 34, one's in purple. Next interval was between 160 and that's the next interval. Next interval was between this. All right, so the intervals are the difference of your cumulative frequency. Those are your frequency values. All right. Everybody go to that?
Yes, sir.
All right. So let's fill out these now. So to fill this out, I need to multiply these two values. I'm going to multiply it on my phone right here. 15.5 times 22. I'll put that value here. All right. That is that is 15.5 times 22. That's 341. And then multiply these two. All right, so that is 45.5 times 36. That gives us 1638. And then the sum of the frequency, sum of fx to get the mean, and the sum of fx to get the mean. They won't ask for this column unless they ask them to find the mean. So I need to add up all these values. Right? The total number of values already is 100. We know it's 200, sorry. I already know that this is 200. If you want, you can actually add them up, and it must be 200 if you add up these values. All right, so the sum of f, which is n. N is the sum of f. N is the sum of f, which is 100. I know we're trying to work out the sum of fx, which is sum of approximate total time that all the students took. And you add this up, all right? So, all right. Let me get the calculator and show it. Adding up this frequency. So it's 66 plus 341 plus 1071 plus 2982 plus 1638 plus 222. So that's 6320. That's some of the sum. All right, that is that. Next one says use information in the completed table, calculate an estimate of the average time taken by the student. That is the mean they're asking for, the mean. So the mean, that is the mean, i.e. the mean time. Which is the sum of fx divided by the sum of the frequency. All right. So the sum of the sum divided by the number of students. So it's 6320 divided by 200. So equal this. Where is it? So it's 6320 divided by 200. And that's 31.6 minutes. I have to say minutes. The data is in minutes. The data is in minutes. That's the average time taken. That's it. Any questions there, guys? What okay?
Yes, sir.
All
Yes,
right,
sir.
so that was January 2023. The next one I gave you, I think I gave you June 2023 as well. So we'll go and see if I can find that one. I also gave you June. I got delivery started from 2023. Let's see. Yeah, I gave it June 2023 as well. So let's go. 2023. Right here. All right, let's go. Bam, 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 bam. This is it. All right, so number 5 is 36%. All right, so this is what they gave us. They gave us a bar chart. Right? In the previous question, if I should ask you why was it an estimated mean that was found in the question we just did, it will be because you don't know the actual time taken by the students in the groups. All right, you don't know the actual time taken by the students, and therefore the mean is just an estimated mean because we use the group midpoint to represent the time taken by each student in the group. And it's not true that all the students in a group took the midpoint time, but that's what we use for the purpose of estimating the mean. All right, let's go. This question says, each of 75 girls recorded the name of their favorite sport. So the total number of girls is 75. This might become important, so take note of it. Eh? Statistics, everything is important. It says the number of girls who chose track and cricket are shown. So we have these two, track and cricket. That's what they gave us. So they don't give us swimming, they don't give us tennis, they don't give us football. Well, the total must be 65. Let's see what number this is before we start. Number on this one is 12. Might need that as well. The number on this one as well. Let's read the scale. Scale of this graph. As this, there are how many lines up to here? Well, right here says 2. So right here says 1. Remember the number of girls. The number of girls. So right here is 1. Right here is 3. Right here is 6. So right here is 5. All right. So right up here is this is 18. So right halfway here, so must be 17. Let's establish that. So that's 17. We have so far, right? All right, let's continue now. It says, how many more girls choose cricket than track? See there? Cricket and track. So how many more girls? So it is 17 minus 12, that's 5. So 17 minus 12 equals 5. 5 more girls choose cricket than track. But okay with that? Nice and easy. But good?
Yes, sir. Yes, sir.
All right. It says 11 girls recorded tennis as their favorite sport. So 11 girls recorded tennis right here. Let's just put on it from now. We're gonna have to draw the bar. I know we're gonna have to draw the bar. That's how these questions are. So since they tell us this, 11 girls recorded tennis, I'm just gonna put it on from now. So tennis is 11. See 11 here, so 11. So the tennis coming up to here. I'm just gonna put it on from now. Before I'm doing anything else, I know I'm gonna need it. So that's might make sense. Just put it on from now. This is 11. All right, let's shade it. That's 11. Tennis. All right, what is it? It says for the remaining girls, the number who chose swimming compared to those who chose football is in the ratio 2 to 3. All right. So the remaining girls is in the ratio 2 to 3. All right. So let's look at it. For the remaining girls, the number of girls who chose swimming, let's put S under the 2. So swimming 2, number who chose football is in the ratio 2 to 3. 2 to 3. I'm just pulling out the information from the reading. I don't like when my information in math is tied up in words. So I'm pulling it out. 2 to 3. And that's of the total remaining. So let's look at it now. What is that total remaining of the total? See, for the remaining girls, what's the remaining girls? The remaining girls, remember, so we have 11 years now. We have 11 for tennis years now. So the remaining girls would be 75 minus these. That's remaining girls that we have so far. And we're going to break this ratio between swimming and tennis now, 2 to 3. All right, so let's see what the remaining girls they have to put in the ratio 2 to 3. So it's 75 minus the sum of these 3. All right, so let's do it up here. The remaining girls, 75 minus the 11, that was the tennis, the 12 and the 17. 12 and the 17. To see what the remaining is. That we have to put in this ratio 2 to 3. So I'm just going to work that out here quickly. And it's going to be, just don't have to come off the screen, it's going to be 75 minus 11 minus 12 and minus 17. So I'm dividing 35 in that ratio. All right. So the total parts of this is actually 5, right? Can do this 2 ways. Total part is 5. So this is 2/5 of 35 comes here for swimming. And 3/5 of 35 comes here. And what you could do is extend this ratio to the total remaining, to the remaining students. And the remaining students would have a total part of 5. But the actual total remaining is 35. So to get the ratio to reflect the actual total, I need to multiply this 5 by 7. Multiply by 7 to see what the actuals are. So the remaining becomes 35. Then these two parts that we're trying to find, this times 7 is 21, and this times 7 is 14. So 14 is a number for swimming, and 21 is a number for football. We can do it that way. All right. It says use this information to complete the bar chart. So I'm going to put 14 for swimming, 21 for football. 14 for swimming. So this is the 14 mark. All right. So I'm going to the bar for swimming coming up to 14 right here. Put 14 on top. And the football also came up to 21. Let's get it properly. This is 20, 24. Right here is 22. 21 is right in between here. All right. So 21 is right in between here. So, all right. So this bar coming up to the halfway mark, the football one. So it's coming right up to here. That's 21. I'm going to put 21 on top there. And let's shade this one as well. That is your bar graph. But okay with that? And these must add up. These must add up to 75 girls. But good with that?
Yes, sir.
All right.
Yes, sir.
Next part now says what determines the modal sport. The modal sport corresponds to the tallest bar, the one with the highest frequency. The modal sport is BAM, football. One that most girls did, football. So the modal sport is just football over there. That's it. One with the highest frequency. All right, 1 mark for that. They said no. One girl is selected at random. What is the probability that she chose neither track nor cricket? So if she chose neither track nor cricket, we're talking about a girl who chose the other sport, neither track nor cricket. So you're talking about these. You want to get one of those girls. So the track and the cricket here, you don't want them. So you're talking about the other girls. Right? So you're going to add up these 3 to get that total number of girls. Or you could do 75 minus these 2. You don't want them. Right? Anyway, take it. These are the ones that you want. They are the ones doing neither track nor cricket. They want to know how many girls that is out of the 75. So that probability becomes equal to, I can also write equal to, it is 14, 11, and 21. 14 plus 11 plus 21 divided by the total number of girls of 75. 75. That is the answer. Whatever that works out to. Let me put it here. So let's see what I get. You can fast 14 plus 11 plus 21. That's 46 out of the 75. That's the probability. But okay with that?
Yes, sir.
All right. Next part says the information on the favorite sport of the 75 girls is to be shown on a pie chart. Calculate the sector angle for football. The sector angle for football is going to be, remember the sector angle is out of 360, you know, right? Total angles in the pie chart are going to be 360. So it's going to be the number for football, which is 21 out of the total shown. I show that know what fraction of 360 that is. That's the angle for football. All right. So you're going to say the angle for football. I can just call it football angle. It's going to be 21 out of the 75 girls. That's a fraction of the total of 360 degrees. That's going to be in the pie chart. That's going to give you the angle for the football. But understand that?
Yes, sir.
All right, 21 divided by 75 times 360. That's 100.8 degrees I'm getting. That's the answer. That's a sector angle. Because football is 21. So it's a fraction of the students. And that football is multiplied by the total angle in pie chart, 360. All right, that question is done. Nice and easy. Very good.
Yes, sir.
Beautiful. Remember, anything you get wrong, you're going to redo it. Anything you got wrong, you need to go and do it again. More maths equals better maths, right? All right. I don't know what's coming in the exam. If I repeat a question like this, you want to get it right. All right. Let's see now. Boom, 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 boom. So it's 2022 next. 2022. 2022, January and June. I gave you. 2022. All right. Let's do the 2022 right here now. This is the June 2022. Let's see this one now. Number 5. It's number 5 on your paper. There you go. I think this is it. Yep. 2022. What a question look long. A lot of table. Anyway, it is what it is. Everybody doing the same. Everybody doing the same question. So don't worry about whether it's long or short or hard or whatever. None of them are hard. It's the same for everybody. Everybody in the same paper. All right. This one says, a school nurse recorded the height 8 centimeters of each of 150 students in a class. All right. In a class A, who was vaccinated. The table below shows information and it's grouped. It's grouped. So between 60 and 80, and this one is including the 80. All right, and not including the 60. And that was 4. And this one is between 80 and 100, including the 100, not including the 80. So the 80 belongs to this group. Sometimes they give it like that, right? Sometimes they give the data such that the value up here is the upper, that's like the upper boundary value already. Okay, so where this ends at 80, it starts back at the exact 80. So these are your boundary values. These are actually your boundary values. So if you draw a histogram for this, these are your boundary values. And to draw a cumulative frequency graph for this one, looks like you're going to be using less than or equal to upper limit value. So the less than or equal to graph we'll be drawing for this one. All right, but let's continue. All right, so there are 4 in this group and so on. So that's the frequency values over here. And this must add up to the total number of students of 150. So this must add up to 150 down here, if you add it up. All right, I'm not going to bother test it, but you know, if you add these up, you're supposed to get 150. All right, let's continue. It says, complete the table below and use information to calculate an estimate of the mean height of students. Give your answer correct to 1 decimal, please. So this is how you see they're actually helping you. They put in the midpoint column for you already, representing the group. So the midpoint is the average of these boundary values. It's a 70 right there. So this is basically saying or assuming that all 4 students in this group, all of them measure 70 centimeters, which is not true. That is why the mean that you calculate from this data is estimated mean, because the fact of the matter is that the 4 students in this group, for example, you don't know what height they actually are, because you're just given a group of data. But for the purpose of estimating the mean, we are assuming that all 4 of them measure 70 centimeters, which is not true. And that's why the data we get is an estimated mean. All right, so if you look at it now, there's no calculation needed for this. You can just observe. These values going up by 20. by 20, right? The lower boundary value is going up by 20. The upper boundary value is going up by 20. The class width is going to be 20 if you draw a histogram. Everything is going to be uniform by 20. So the midpoint also increasing by 20. So if this is 110, then this is 110 plus 20 is 130. I can check it because 130 plus 20 gives it that 150. So you know that the 130 here is good. And then now to get this value now, we need to multiply these two. All right, multiply those two to get the value over here. So we can do that. Let's do that off screen. Let's write the value there. All right, so I'm just going to multiply these two values. 67, so there becomes 67 times 130 to get the value over here. 67 times 130. And that is 8710. Then I know I'm going to need a sum of fx. Remember, fx is my sum column. It's your way of adding up the height of all the 150 students. See, this is the 150 students, n, which is the sum of the frequency, is 150 students. We need the sum of all the students. It's a quick way of getting the sum of all 150 students, sum of the height of all 150 students. That's the sum of your fx. And I'm just going to put it here because we need it. Let's just work it out from now. Let me get a calculator and show it. I know we're going to need that figure, so it makes sense. We just work it out from now. You need to find the mean. Let's add them up. So it's 280 plus 1800 plus 3850. I'm adding up all these values, guys. All right, plus that is 8710 plus 3000 plus 680. So the height of all the students combined is approximately 18,320 centimeters. All right, and therefore the mean height is this total height divided by this number of students. That's what I want us to calculate to one decimal place. So if we divide it, that's where I put it. We need the answer right here. So the mean, which is the average, is the sum of the sum divided by the number of students, which is 18,320 divided by 150. Do this calculation. That's what we get on here. So it's 18,320 divided by 150. I'm getting 122.1, and I said to one decimal place. So I'm putting equals 122.1. I have to write centimeter. You have to write the unit. That's the mean height of a student. 122.1 centimeter. You have to put the centimeter that the data is measured in. I have to put it. Got to go to that? But okay?
Yes.
All right, beautiful.
Yes.
Only now says, in class B, the mean height, all right. In class B, the mean height of the students is 123.5. That's higher than this one, right? And the standard deviation is 29.87. It says for group A, the standard deviation is 21.8. So this is something that I have not yet covered in class, but this is the extent to which CSEC will ask a question about standard deviation, using standard deviation. So I'm just going to take a minute to kind of explain this interpretation. Right? Let's write out the data here. Don't like information is hidden in words. So for class B, class A, the standard deviation in class A is this, right? It's 21 point that. So the standard deviation is 21, and the symbol of a standard deviation is this. But I'm going to write ST for now. Standard deviation is 21.38. And the mean up here was 121 point. But that's not really important. And the actual value of the mean not really important. All right, in comparing standard deviation. So class B. class B, the standard deviation, they tell us, is higher, this 29.87. All right, let's talk about standard deviation a little bit now. So standard deviation is a measure of spread, measure of how the data is spread. But importantly, it is a measure of how the data is spread from the mean. That's what it is. It's a measure of how the data is spread from the mean. So this lower standard deviation means that for class A, the height of the students are more closely spread from the mean height because it has a lower standard deviation. Over here in class B, because the standard deviation value is higher, it means that in class B, the height of the students are more widely spread from the mean height. So let me use some figures to show you now. So I'll look at a diagram to show you. All right, let me use a little diagram to show you. All right, so let me use an example where you have two groups and each of them have the same mean, just for emphasis, right? So let's say the mean of two groups. Say you have group A and group B. Just explain it, right? I'm going to use the same mean to kind of give the emphasis. So you have group A and you have group B. Two groups, right? And let's say the mean for group A. What am I writing? Let's say the two means the same. So the mean, let's say the mean is 100. Let's use in 100. Because the mean is 100 anything. So 100 centimeters. Let's say it's height of people. And for group B, the mean is also 100. Just to keep it, make it more clear. Now let's say for group A, right? The standard deviation is equal to, let's make the standard deviation for group A be equal to 20. And the standard deviation for group B, let's make it less. Let's make it be equal to 10. Now what this 20 means is that the height of the students deviate from the mean to about maybe 20 more than the mean. So it might go up to 120 centimeters and to about 20 less than the mean. So this one might go down to maybe 20 less, maybe 80 centimeters. So it's like this standard deviation is suggesting that the height of the students in group A, if we're talking about height of students, is deviating wide between 80 to 120, about 20 less than the mean to about 20 more than the mean. In group B, because the standard deviation is 10, it means that in group B, the standard the mean height, the height would deviate 10 to the right of this, maybe up to about 110, like a closer, and to about 10 less, which would be about 90. So you see, from this little illustration, when the standard deviation is larger, it means that the data is more widely spread, from the mean. Let me shift this over. The data becomes more widely spread from the mean. It's always from the mean. A standard deviation is measuring spread from the mean. So you have to see it from the mean. Very important, right? And in this case, because this one is smaller standard deviation. This one is a smaller. Then it means that the spread is just this. It's closer, more closely spread from the mean. Not as wide as this one. This one go all the way also. This one is just from here to here. So here now, I said this one is less widely spread, or you can say more closely spread. And the standard deviation is less, means that the data is more closely spread. So this one is a more closely, when the standard deviation is lower, the term you want to use is more closely spread from the mean. I need the word spread inside here. More widely spread from the mean. More widely spread. The measure of spread. Let's write it properly, Mr. Shaw. We need the word spread out here, the measure of spread. And here it is more closely spread. From the mean. All right? And you're really comparing the two sets of data. So one is more widely spread than the other from the mean. Right? But the fact of the matter is that the mean don't have to be the same. So even the mean is not the same. Once the standard deviation is less, right? Even if the mean was different. Once the standard deviation is more, it means that the data is more widely spread from the mean in comparison to the other one. And that is what you basically, so these are some of the terms that you want to use to give your interpretation of the data. Think you understand that, guys? I just use this little quick illustration to try give an explanation of how you analyze standard deviation. Remember, it is from the mean as a comparison. CSEC wants you to compare two standard deviations. The higher one will result in the data being more widely spread from the mean, and the lower standard deviation will result in the data being more closely spread from the mean. And it is in comparison to the two sets of data. It's a comparative sort of thing. You're comparing data. Think you understand that, guys? Think you understand that explanation?
Yes,
good. You have to understand it first, and then it's a matter of writing it yourself. All right? So let me write this one now. So let's look up here now. So up here now, the two mean different, you know. So the mean for group A, we had it up here. But as I said, the actual valid mean is not important. And the mean for group B, was this mean right here, a larger mean, but it doesn't matter. It is the value of a standard deviation that determines all spread. So because this one is a smaller standard deviation, this is the one that's going to be more closely spread. Smaller one is going to be more closely spread. The data is more close to the mean, more closely spread from the mean. And the one with the higher standard deviation is going to be more widely spread from its mean. So these are some terms that you want to use. Widely spread from the mean. You have to say it from the mean. If you leave out from the mean, you're not going to get the marks, you know, guys. Standard deviation is measuring spread from the mean. Even if them don't tell you the mean, you have to use those terms. All right. So it says no. It's not a lot of mark. There's 1 mark for it. We want to get the 1 mark. It says using the information provided and your answer response from A, comment on the distribution of the height of the students in both classes. Class A have a lower standard deviation, as you can see, so it's going to be more wireless, more closely spread. Class B has a larger standard deviation, so it's going to be more widely spread. So you give your answer with A as your reference, or you give your answer with B as your reference, but you're comparing them. You get me? So whatever you write that says something like that is your answer. Once it says something like that, don't have to be verbatim. All right. So for example, I might say, because class A, and I will leave this on my exam paper, because I want to convince the examiner that I know what I'm doing. So I would leave these on my exam paper for them to see. All right. So I can say, all right, I remember you're comparing. So everything is in comparison. So you can give it as A as a reference in comparison to B, or you can give it B as a reference in comparison to A. So let's say we're using A as a reference. All right. So we're going to say it like this. We're going to say the height is the height of the students, The height of the class A students. And the class A one are more closely spread, right? Closely. More closely spread. More closely spread. Right, of a smaller standard deviation. Right. So the heights of a student in class A are more, height of a class A students are more closely spread from their mean height. HEIGHT, mean height compared to the students in class B. You get the marks if you write that. If you're writing it with B as a reference, so we shift these down and write it with B as a reference now. So writing it with referencing from B, right? Then we're going to get a different color. So write it like that, or you can write it like this. Referencing B, I would say the height of the class B students are more, so the class B have a higher standard deviation, so the data is more widely spread, are more widely spread. Data spread out more wide, wider, more widely spread. From their mean height. So you see, I have to put in this line. I put in from their mean height. You have to put the word mean in there. It's a spread from the mean, from their mean height. Compared, the comparison again. Compared, I need to D right on this one. Compared to the students in class E. So any of these two things are right. This or this, you're good to go. And the important thing again, I'm underline it. You have to say this thing. From their mean height, you have to mention the mean height. The spread is from the mean height. The spread is from the mean height. I have to put that in there, otherwise you're not going to get the mark. You're not going to get the mark if you don't put that. If it was 1 mark, do it properly, ensure that you get the mark. But good at that? But okay?
Yes, sir.
Yes, sir.
All right, beautiful. Remember this. The bigger standard deviation means that the data spread more widely from the mean. Smaller standard deviation means that the data spread more closely. The heights of the students are closer to the mean height. So basically, if I look back at this again, it's like in this class, where the standard deviation is higher, it's like there's a person there with a height of 80 centimeter, and there's a person there with a height of 120 centimeter. So like the smallest height is 80, and the largest height is 120. For example, when the mean height being 100. Over here, when the standard deviation is less, means that the smallest height is 90, and the largest height is 110. So if you notice, the spread is not so far from 100. While up here, the spread is wider from the 100. So that is it. Hopefully you understand. But that finishes that question. Oh, we'll come on to here now. Part C, which is a cumulative frequency. And I guess they want us to draw the curve. So they give us the table there and want us to finish. It says, complete the cumulative frequency table below and use information to construct the cumulative frequency curve on page 19. All right, so it started for us. And I just to get this value, I need to just add the 35 to this. Add it. The next frequency, right? So it's 35 and that makes 59, right? 59. Let me write it out here. So give it the frequency plus thing there. So it's 24 plus 35. All right. And so this becomes 59. Then down here now, I'm adding 20 to this to get this one. All right. So 126 plus 20. 126 plus 20. That one is equal to 146. Then 146 plus the 4 give you 150. So know that those values good. That is it. All right. Then it says, we have to draw the graph now. So remember, when you're drawing the graph, you're going to be drawing upper. These upper is going to be upper. Is really boundary values these now. With less than or equal to, you're going to be drawing, right? And the cumulative frequency value. That's what you plot. Remember, you always close the graph down to 0. So the value before this would have been 60. See, it's going up by 20. So the value before this one would have been 60. And that has a cumulative frequency of 0. Let me mark this better and show you. Let's mark this better, Mr. Shaw. So I'm using all of these upper boundary values. The value before this would have been 60. Let's put it up here, so. And using these cumulative frequency values over here. Let me draw it up here again. All right. And that cumulative frequency would have been 0. That's a point you need to add to your graph to bring the graph down to the x-axis. And you're plotting upper boundary values against the cumulative frequency. But these boundary values are actually less than or equal to values. Where's the graph? Where's the graph? Right. Oh, they actually put on some of the points for us already. Right? They actually put on some of the points for us already. So you see they put on the 60-0 for us already. I was telling you, see? They put it on for you already, 60-0. So which point is missing? The point that is missing is 120. It's 120, 120, and 160. Those are the values missing. All right. 120 is what? Let's equal to 120 is, oh, the two that we did not have on the table, 59. So these two that were added are missing. So if I put them on. All right, so 59 and 160, 146. So we need to put on 59 and 146. All right, so if you look at the scale, guys, I'm going to be careful, So look at this now. Look at the scale, if you get it right before we start. So there are 5 lines, 5 of these little lines, up to 10. So it's 10 divided by 5 lines. So each line is 2. All right, so each measure here is 2. So this is like 2, 4, 6, 8, 10. Make sure All right. So on the 120, we need 59. All right, so look for 59. So it should be 50, 52, 56, 58. No, 52, sorry. 50, 52, 54, 56, 58. 59 is right here. This is 59. 59 is right here. This is 59. Right here is 59. Everything important. Mathematics is the most exact science. Get it right. That coming right over to the 120 line. 120 line is this. It coming right up here. So the mark is right there. All right, that is it. The next mark is how much you say? 146. All right, so this is 140. Every small line is 2. So 140, 142, 144. This is 146. 146. So you come across here. And I'm coming over to this 160. This is the 160 line up here. All right, so we're talking about right here. That's it. And then you draw O give through those points. Smooth curve, do not put any straight edge ruler on it. Draw a best smooth curve through those points. Let me start blowing for it. All right. So it's gonna go like this. Now sketch it out first. Sure, no. That's it. That's my curve. That's my O give. Another name for the cumulative frequency curve is the O give. These are the 2 points that I put on right here and right here. All right, that's it. All right, so draw the graph. What else I want to say is, it says, use your cumulative frequency graph to find an estimate of the median height. How many students are there again? 150. So the median height corresponds to the height of the 75th student. Half of 150 is 75. So 75 would be, let me get a different color for that part. 75 would be right here. That's half of 150. That's the position of it. That's not the median height, that's the position of the median height, right? So this is the position of Q2. So to get it now, you come across on the graph and then you read it down here. Looks like it is right in between here. Let's read it down and see what we get. Let's read it down all the way down to there. Let's get a scale on here so now. So on the horizontal axis, there are 10 of these lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over an interval of 20. Each line is 20 divided by 10 is 2. All right. So each of those little lines is 2. So this is 120, 122. It should be 122. It should be 124. So right between them. So this is 123. So this now is your median Q2 it is 123. Unit of measure centimeters. 123 centimeters approximately. That's an estimate. All right, I'm going to leave those marks on the graph. Where is it? 123. 123 centimeters is a Q2. All right, and I've drawn lines on the graph to show how I get it. So those lines, I'm going to leave them on the graph, these. Leave them on the graph. What else I want? They also want the probability that a student chosen at random would be taller than 130. Taller than 130. And I wanted to use the graph. Because what could have done now? We could have come inside here and say, okay, 130. But you can't get it from this exact. I don't know where 130 is. So you're going to have to get it from the graph. So you want to know who taller than 130. But the graph is going to show you who less than or equal to 130 first. That's what the graph is going to show you first. But you want the rest of them. So the graph is going to show you first who is less than or equal to 130. So less than or equal to 130 centimeters. How many students that? How many students? Let's go on the graph and see. Down here, 130 students. So this is 130 is right here. Let's use a reading for that. So this is 120, 140. This is 130 right here. So 130. All right, so come on the graph. So you really want the students out here now, those who taller than 130, those heights. Well, let's see how many students less than 130. So I'm coming up on the graph on this 130 line. Coming up on the graph on this 130 line until I meet the curve. So this is my graph. It looks like it come all the way up to here, saying looks so. Looks like 100. But let me not assume it's 100. Let me go a little bit less. Let me say it come to about here. It first meet the graph. And then come across and read it here. What is that measurement? But it says 90, 92, 4, 6, 8, 100. This is actually 98. So 98 students measure less. 98 students measure less than 130. The one who measure more, which is the 150 minus the 98. The rest of them are the top. All right? And you want that as a probability out of the 150. All right? So see here now, back to this question now. So let's say I go to 130 centimeters is 98 students. Is 98 or 190? Let me make sure. Yeah, 98, which 100? 98 students. The rest of them measure more. Therefore, greater than 130 centimeters is 150 students minus 98. The rest of them. That's what they're gonna do. And then you do that as a probability. Out of the total of 150. What is your quarter? Minus 50, 52. 52. It's 52 students. Therefore, probability of being greater than 130 centimeters is the 52 students out of the 150 students. That's what they're working out. That becomes 26 over 75 if you reduce it. 26 over 25. I don't think I can reduce it anymore. Better go to that.
Yes, sir.
All righty. All right, I think that finishes this question. Yep. There's a solid geometry question right here, you know. I don't want to do this one today. We're going to do this solid geometry in a different class. But this is topic I will just do. So this will be a nice question to don't know, but yeah, we get back to it. Let's stick to the statistics. We're going to have a class over the solid geometry. All right? Solid geometry. Practice. But let's just continue with this. All right. So we're going on to I think January 2022. I don't think we do January 2020. This must be about third question. January 2022. January 2022. Number 5, we're looking for number 5. Yeah, another similar to solid geometry question. See? There you go. There you go. January 2022. All right. Must so long, we're going. I don't like when the Saturday sessions are too long, because I want persons just to remain focused. So let's see how long we're going for. We're gonna go 40 minutes based on this. Oh, 1 hour 20 minutes are gone. 1 hour 20 minutes. Oh. All right, we could continue. Maybe 1 or 2 more questions. All right, this one says, the cumulative frequency diagram below shows information about the distance, kilometers that each of 120 students walk to school on a particular day. All right. So remember now, these are the students up here, and these are the distances that they walked less than. Either less than or less than or equal to 1 to the 2, right? Whichever one you decide to use, a lot of the time don't make a big difference. But sometimes as you read the question, you'll know which one you have. All right, let's see. All right, so this one says, how many students walk at most 1 meter? So this word, this term at most, it means less than or equal to 1 meter, 1 kilometer. So it looks like it's a less than or equal to graph I have. So I'm going to decide that it's a less than or equal to graph based on the fact that they asked us this. Because at most means that 1 kilometer is the most. So you want who walk less than or equal to 1 kilometer. That's what the term at most means. 1 kilometer is the most. That's what the graph is showing us. So I'm going to put this as a less than or equal to distance graph. All right, so I just need to find 1 kilometer and see how many students that is. So 1 kilometer here. I'm going to see how many students that corresponds. Easy as that. So come on the graph here. Read across. Talking about right there. We're going to get the scale right before you start. So there are 10 lines. See? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 spaces up to 20. So it's 20 divided by 10. So each of these little units is 2. 2 students, right? So each of these little units is 2 students. All right. Make sure you get that right. So this is 10. This is 30. This is 32, 34, 36. That's 36. This is 36. Leave it 30. This is 36. I don't say it's 36. 36 students walked at most. 36. Just remember that the term at most means 1 is the most. So if at most is 1 kilometer, it means that you're talking about how many people walk 1 kilometer or less. So that is 36 students. 36 students is the answer. But okay with that? Nice and easy.
Yes,
Very good?
sir. Yes, sir.
Right. Next one says, using the cumulative frequency diagram, determine an estimate of the median. The median corresponds to Q2. So we need to find a portion of Q2. Then the one, the lower quartile, that's Q1. All right, and then I want the interquartile range, which is Q3 minus Q1. So we're gonna need Q3 as well. All right, let's go. So Q2 first is the median. So what's the portion of the median? 120 students. So half of 120 is 60. So look here. These are the students, you know. You can find the quartile by dividing it half and half first, you know. 60 and 60. Right inside here is the position of Q2. Then halfway between here and here is 30. So this corresponds to your Q1 and position of Q1, you know. And then halfway between 60 and 120 is 90. See 90 here, so that corresponds to your position of Q3. We could also use a formula way to do it and say half of the portion of Q1 is half of 120, which is 60. So this becomes a position. This is a position of Q2. Not Q2, no, it's a position of Q2. Get the Q2 come across on a graph, read that distance down on the x-axis. All right, so we have to figure out the scale now. So look at the scale now. So for the scale, there are 10 lines. 10 lines. Sorry. The unit is sorry. So it's 0.5 divided by 10 spaces. So each space is 0.05. So then every 2 spaces is 0.1. So look at it this way. So this is 0.1, 0.2, 0.3, 0.4, 0.5. So every 2 lines is 0.1. Right? Look at it good. Every 2 lines is 0.1, then 0.2, then 0.3. That so you can see it good. Extend this down just to make sure you can see it good. So 0.1, then this is 0.2, 0.3, extend this down, that's 0.4, then 0.5. So every other line is 0.1. And every space is 0.05. All right? So I'll make sure you get that. So therefore, what is this? What is this? This is 1. This is 1.1, 1.2, 1.3. Continue checking it. That will be 1.4, 1.5. Right? So continue checking it to know that this is 1.3. So this is actually your Q2. 1.3 kilometers is a Q2. Corresponds to 60 students. So this is 1.2. Q2 is 1.3. Q2 is 1.3 kilometers. We need the first quartile. First quartile is 1 quarter. The position of Q1 is 1 quarter of 120, which is the 30th student. 30th student in the 30th position. As I said, you could divide it half and half, and then half of the 60 is 30. So this now is the position of Q1. So you come across on the graph. See the graph right there. And you read that measure down here. You're gonna have to figure out now what it is. Be careful. So it's actually 0.9, you know, because it's 2 spaces less than this 1 right here. So it's actually 0.9. If you check it, look at it. This is 0.5, 0.5, 0.6, 0.7, 0.8. Let's go again. Let's go again. Let's go again. 0.5, 0.6, 0.7, 0.8. This is 0.9. All right, so this is 0.9. This one, 0.9. 0.9 is your Q1. All right, 0.9 is Q1, 0.9 kilometers. So Q1 is 0.9 kilometers. Q1. Let me erase this. Then I want the interquartile range. So we need to find Q3. So let's write down Q3 over here. So what it is. So we can subtract them. So see you know the position of Q3, if you want to calculate it, is 3/4 of 120, which becomes 90. The 90th student is in the Q3 position. So you come up on the graph, find the 90th student up here. This is 80, that's 100, so right here is 90. And that is the position of Q3, third quarter, 90th student. We did the third quartile time. So come across on the graph, come across until they meet the graph right here, and then read that time down on the x-axis. Down here on this line. If you draw these lines on the graph with your ruler, it's basically you showing the examiner how you got it. Let's read this one carefully now. So this is 1.5. This is 1.6. Halfway between 1.5 and 1.6 is 1.55. So right here is 1.55 kilometers. And that is your Q3. 1.55. Q3. So this down here is 1.55. And so this interquartile range becomes equal to 1.55 minus 0.9. 1.55 is Q3, 0.9 is Q1. So that is that is 0.65 kilometers is the interquartile range distance. All right, but go so far? But okay with that?
Yes, sir.
Yes,
All right.
sir.
All right, anything you get wrong, go and redo it. Question says, a student is shown at random. What is the probability that he walked from more? He walked from more than 1.5, means greater than 1.5 kilometers. Remember now, the graph is going to show you how many took less than or equal to 1.5. So see you know, less than or equal to 1.5 kilometers was done by how many students? Let's go on the graph. 1.5. All right, so 1.5 here. Let's use a different color for this part. So it's 1.5 here. So that's right up on this line on the graph. This one is 1.5 kilometers line. They're going to show you how many students walk less than or equal to 1.5. Right? So less than or equal to graph, you said that. The rest of them walk more. Let's zoom up here and see where we reach. So we reach right here on the graph. So you come across and read the number of students up here. What did we say? Every small line is what? What did we say again? Mark it down here, so it's kind of good to put it down here, so you know. So it's 20 divided by 10. Each small line is 2. Right? Just says 2. So you put it down here so you don't forget it sometimes. It's a little space is 2, so it's 10, yes. So right up here we want, this is 82. 80 and one small space, that's 82. So 82 students walk less than or equal to 1.5. You want to know how many walk more. So the difference. So less than or equal to thing was done by 82 students. Therefore, more than 1.5 kilometers was done by 150 minus the 82. 150 students minus the 150 students total minus the 82. All right. And that is 68 students. What more? So why these students trying to get the probability of 4? So therefore, the probability for going greater than 1.5 kilometers is therefore these students who did it out of the total of 150 students. That's what they want. That's what they want. So you can put this as a decimal, simplify it as a fraction, however, whichever way. That will be 34 over 75. 34 out of 75. That's the probability. That's the answer. But to go to that.
Yes, sir.
Down here now. It says complete the table below and use information to calculate an estimate of the mean distance walked by the students on that day. All right. So these are the midpoint values. If you notice, these values going up by 0.5. These values going up by 0.5. So the midpoint values also going up by 0.5. So you can fill in this one easily. Sorry. Where are you? All right. So we're gonna add 0.5 to this and get 1.5, 1.75, 1.75. That's the midpoint. Then now your frequency. Now, what you want to know is to find the number of students in this range to fill in here, and the number of students in this range to fill in here. All right, so you can actually do it on the graph. All right. So you can look how many students were there between 2 and 2.5. Fill in here, and then since you know the total is 150, you can actually just subtract 150. Subtract the total from 150, whichever way. All right, so you can go on the graph and look between 2 and 2.5, how many students. But that, we know 1 already, you know. We know 1.5 already, you know. So it kind of makes sense to work with 1.5 and the 2 that we already know. Let's see, we know 1.5 already. Because 1.5 here a while ago correspond to 82 students. It's here 1.5 here corresponding to 82. So we need to know what 2 corresponds to. 2. And the difference is in the interval. So the 2 now, open the graph and read the 2. And so the 2 come to here. I can also read the 2.5 same time. See 2.5 here. And they get all those marks. But those are your boundary values. Right? So this one up here so is 118. 118, 118. So the last interval is 2. See there on the table. The last interval is 2. See there up to the top. All right? And the interval before that is only this one. We need to know what this mark is. So come across on the graph, look at it carefully. It's right in the middle here. Everything must match nicely. Let's read that now. So this is 100, this is 110, 102, 102, what, no, not 2, 112. This is 114. So inside here is 113. All right, read the graph carefully. So this is 113, 113. So this interval is the interval. So the top interval is 2, right? The top interval between this and this, between those two boundary values is 2. Which we'll have those values on the table. This interval is 5. From 113 to 118. That interval is 5. We come up on the table. So the frequency in that interval is 5. Let's put on the table. Where are you on the table? Right here is 5. Come on in blue. This interval is 5. And then this interval now, let's look what that one is. 5. So the one between 1.5 and 2. Let's look at that one. Between 1.5 and 2 is between here and here. That interval is 113 up here, so minus 82 down here, so that's 31. That interval is 31. Inside there is an interval of 31. 113 minus 82. 113, that's 831. In the table, right here is 31. And then to know if you're right, if you add up these, you must get that 150. All right, if you add up those, you must get the 150. Let's check it. You won't get the 150. Something is wrong. Something is wrong. Let's check it. So it's 12 plus 24 plus 46 plus 31 plus 5 plus 2. Not 150. I said 150. I mean 120. My mistake. 120 I'm supposed to get. 120, yes. Because I remember it was 120 students, right? See there. Highest cumulative frequency is 120. 120 students. I said 150 should be 120. It is correct. So it is correct. 120, not 150. And then now to complete this table, now we need to be multiplying these values to get this and to get that. Multiply them. Let's do it on the table. So it is 1.75 times 31. That's 54.25. And then this one now, that is 2.25 times 5. That's 11.25. All right, that's the something now. So this one is the sum of f, which is 120. And then here now you have the sum of fx, which is sum of the sum. So adding up these values now. The total of all 120 students. Total distance. So it's 3 plus 18 plus 57.5 plus 54.25 plus 11.25. That's 144 flat. Let's check that. Or I didn't add this last one, plus 5.5. So I almost gave it away. 3 plus 18 plus 57.5 plus 54.25 plus 11.25 plus this 5.5. That is 149.5. All right. And then now the mean. The estimated mean from the sum of fx divided by the sum of f. This is sum of the sum. This is the sum of the frequency, which is the number of students. So it's 149.5 divided by 120 students. That gives us 149.5 divided by 120. That's 1.2, that's 5 kilometers is the average distance walked. I think I'm going to stop it here for today, guys. I think the next one is going to take us over the 2-hour threshold that we're trying to keep in these sessions. But okay? Are they all right?
Yes, sir.
Yes, sir.
All right, so we didn't do the questions, you need to do them. Especially you can go now and do the rest, the ones from 2021 and 2020. In order to see how these are done and you have the explanation. I'm going to send the video in the group so you can watch over the video. Redo the questions first. If you didn't do them, or if you did them and you got them wrong, redo the questions first before you try the others. That's how you always work. All right, and I see you all in class tomorrow, starting a new topic tomorrow. Starting a new topic tomorrow. I think tomorrow when the rates have changed. What I might do tomorrow is one of those one-day topics. I'll decide later. Because there's something that I needed to bring to class, and I forgot to tell you to get it. All right, so based on that, I think I might do one of those one-day topics tomorrow. All right, I'll decide when I look at it. All right, guys. Bye. You know what to do. Bye, everybody. See you in class tomorrow and Monday.
Bye, sir.
All right, cool. More maths equals better maths every time.